Ladies and gentlemen, Algorand. Now, what is Algorand? So that it is a platform, a new platform for a digital currency. Actually, it's a very efficient one. It is a new platform for fast settlements of stock. And if you have an appreciation for the bombastic, it is actually the linearization of chaos, okay? It is also a bunch of patented patents over there. But given that there's so many things, today, which one incarnation we are going to discuss? We are going to discuss the digital currency with an understanding that the technology can actually be adapted to do other things as well. So given that we talk about currency, here is the history of money, abridged. So once upon a time, we had no need for money. We had better things to do, escaping predators and beasts like this. But as soon as a civilization settled down, we needed money. And the latest arrival here is Bitcoin. And Algorand, also there in blue, is in this tradition. So what do we share with the Bitcoin and a lot of other things in electronic money is about that we are based on some cryptographic primitives. This is, if you don't know what the digital signature are, you're not going to learn from this slide, but I want to establish a notation with you. So essentially, I generate a pair of public and matching keys. I use my secret key to generate my signature of a message M that only I can produce, but everybody can verify your digital signature. So that's wonderful. It's even better than the Scribble because it's really message specific. Only you can do it, everybody can verify. Great. Second protagonist here is the secure hash function. So that is a very fast function. It takes long messages. Anna Karenina, 256 bits, okay? You can read it in 1 minute. So, but actually you cannot quite read it because if there is M, the message has a little bit of entropy, H of M is a 256-bit random number. And also, if you give this digested version of a message, which one was the message? Unless you know it beforehand, you cannot figure it out. However, if I give you the message, you can hash it down and check whether it's the original message they put in. So that essentially, digital signatures and hash function suffice for Algorand or for Bitcoins, but they are used in very different ways. First of all, I'd like to tell them how to use in an ideal scheme. So here we are going to generate them, we want a digital currency. And we are going to be the founding members, so there is going to be an initial endowment. In the ideal scheme, Bitcoin, Algorand, and things, money is owned by public key and is transferred by digital signature. So here's what we're going to do. I create a public key and I endow for $1 billion. Andrew makes his own public key and endows it with $1 billion. We're all democratic and good friends here. Everybody gets $1 billion. And now we start spending money. We need people who accept it. Very good. Here is how a payment looks like. A payment, essentially, is the signature that my public key PK transfer to a different public key PK prime, some amount to A1 prime, and some public key PK2 prime, some amount to A2 prime, and so on and so forth. And on top of it, you notice that this can be some new key, because otherwise we'll be transferring money to each other. So somebody else wants to accept our currency. We say, you want it? I can transfer $100 to you. And this is some additional information that, about the date of the payment that we don't mind making public. And here is some sensitive information which we hash, so nobody can figure out what it is, such as the reason for pending, the merchandise, right, which was shipped to you, and so on and so forth. Good. And finally, there is the magic ledger, and that's what makes this an ideal scheme. So anytime that I make a payment or you make a payment, the payment immediately goes up in the sky and everybody can see each other payments, and they are organized in a very linear fashion, time 1, time 2, nice. Good. So, by the way, from this magic ledger, you can derive the status of the system at time t, which means what? Which public key owns how much money at a given time. But you only need the payments. You look at the payments, right? That is a much larger object. You have to deduce it yourself. But you can. So the goal here and it is a hard goal, by the way, is to get with the same efficiency of the scheme, with the same privacy, because in some sense that is not the reason for the payment may be privatized by the hash function, but if you do a network analysis, you can see that a public key pays a lot of money to another public key. Oh, there must be business partners, and so on and so forth. So you have to do something more sophisticated to get real privacy. And you want to do the same trust, the same privacy, and here the trust is great because the magic ledger is trusted. Good. So Bitcoin tries to approximate in some sense at a 40,000 feet level this. And by the way, when you talk about Bitcoins, we must be cognizant that actually there is several versions, and I think I'm familiar with 2 or 3. So I'm going to somehow summarize it in what I call the essential Bitcoins. Okay. So Bitcoin works as follows. There are all these players, black, purple, red, green, things about 1 million of players. And these are payments that somebody generates, and what do? They gossip around. So I'm going to tell, I've seen this payment, and I tell it to 2 of my neighbors. You see it, and you say it to your neighbor. And very, very quickly dispersing the information. But that is a too nice picture, because remember, the network is very big, messages travel at the speed of light. That's actually what happens, okay? And then when the dust settles, so here is the purple player says, oh, I've seen payments P1, P5, et cetera, et cetera. And the black player says, I've seen P1, I've seen P3. So you see that they're a little bit different with one another because they don't agree on this. And everybody sees his own partial view. So what you could do is that you can sign these players. These are the payments that I recognized, I checked their validity, and I'm going to, and what I can do, I can actually gossip this too, so somehow binding these things. And I can propagate these views, but which view to adopt? You see, these views do not agree. So what Bitcoin does as a great ingenious idea, that doesn't quite work perfectly, but is ingenious anyway. And here is the thing. When you got your view and you have signed it, what you do, you take a random value, R for the black player, and you hash all these things. And you get 256 bits. Look at the last k bits. And you see, in the case of a purple player, they end up being 0, 0, 0. Say 40 zeros in a row. And oops, that is not true for the black player. Well, when this happens, we declare the winner to be the purple player. We ignore everybody else who is not a winner. And then we propagate only the winner's view. In other words, if I tell you my signed block of payments, and you hash them, and you check that the hash is 0, 0, 0 40 times in a row, you propagate it. Else you don't propagate anything. So pretty soon, if there is only one winner, everybody gets a coherent view about which payments have been made. And well, how much is K? Well, assume that K is 20, you need a million times to hash with a random value before you get 20 things in a row. If it is 30, a billion. If it is 40, a trillion. Pretty soon it's going to get a little bit hard to get all these things in a row. So if you choose K properly, depending on the number of users, you guarantee yourself that you have a winner every 10 minutes. So essentially means we see different payments, we authenticated a block, but only one of us, and in 10 minutes, is so lucky to have found this random value that managed your block to be highlighted, and you distribute that. And that's a great idea. But, occasionally there can be more than one winner because, right, you time it things perfect. But you can do 2 winners. It can be 3 winners. And it's a little bit complicated. So you reward the winner, and that essentially is the Bitcoin. So the essential of Bitcoins is the following. The main idea is proof of work. You have to invest time to highlight your consensus. The main assumption is that the honest majority of computing power. And the main problems are there is an insane amount of computation to be done. There is a concentration of power because this insane amount of computation, I cannot do it myself because even though Bitcoin rewards me on my laptop, I spend more in electricity trying to mint a Bitcoin than the reward I'm going to make. So there are only 5 consortia right now that they are mining Bitcoin. So assuming honest majority of computing isn't clear anymore what it means. And then there is also this lingering ambiguity. So we talk about blockchains, but it's actually a block tree, forest, plenty of chains. You don't even know whichever the right one is. And this ambiguity is not good, I think, for commerce proper. And there is issue of scalability. So, and there are also legitimate concerns, law enforcement, monetary policy. And what do? We change the world around. We have a totally different idea. The assumption is majority of money is honest. I think it's a very defendable assumption. And you get incredible advantages. And by the way, if you also have a role for non-controlling banks, which is good for the user and is good for the banks, not only you get the same advantages, but also take away law enforcement and monetary policy concerns, and you get an amazing performance. Thank you. Sorry for being late.